Okay, we are already noon time, so we'll get started, okay?
Okay, okay,
Because
sir.
because a lot of student I know is actually part-time on the actually they have a full-time job somewhere else, not really full-time on this program. So it's okay that if you miss the Monday meeting, okay, it's okay. But usually we welcome to join, okay? We welcome you to join the session because if you have question, this is the best way to communicate. Okay, this is the best way to communicate. Okay, first let's get started with this syllabus. Um, so this course we are on CS65K, okay, robotics. Okay. And when I developed this course, I actually developed course already 5 years. But when I developed this course, I actually struggle for the idea of is this one a undergraduate course or a graduate course for robotics? And actually, the dean of the computer of the school doesn't tell me that whether it's undergraduate course or the graduate course. So you will see in this course we have two set of the slices. Okay, the PowerPoints with two set. One is actually for undergraduate, one is actually for graduate. So actually we don't come to any conclusion that this course should belong to which one. Okay, because this is the only robotic course in Louis, and student did not have the background of any robotics before, so we cannot actually purely teach in the graduate school level, and we cannot purely teach in the undergraduate level as well. So it's very hard. And also, this one is only a 8-week course. It's not a full 16-week course. It's very difficult to organize the material. And there's another limitation that we face is that this one is purely a remote course. We do not have the on-site course. In fact, I'm living in California. I'm not living in Illinois. Okay, so that also make this course hard to include every topics that we want to have. Okay, because I think primarily because this course is an 8-week course, but even that, we try our best to give you a good introduction to robotics. Okay, introduction to robotics. That's what we're trying to do. Okay, and so first, myself. Okay, my name is Eric Chow. You can pronounce it as Chu or Chow. I don't mind, but usually most people pronounce as Chow, CH. So it's similar to CHOW. Okay, if you see some people actually pronounces their last name is CHOW. Actually, it's the same Chinese letter. Okay, and CHOW usually is people from Hong Kong. Okay, and CHOU is usually from Taiwan. Okay, usually from Taiwan. Originally from Taiwan. If you see some people who actually last name is ZHOU, okay, these people from China usually. Okay, but that's the way you know. It's actually this is the same Chinese character. Okay, same Chinese character, and it's a big family. The Chow family actually worldwide probably 50 million of the people. Quite a big family. Okay, only this last name, including like 50 million people on Earth. I think probably one of the top 10 family on Earth. Okay, so it's a pure, very, very huge group of people. So my undergraduate study, I am actually I graduated from National Taiwan University and major in computer science and engineering. Okay. For those of you who don't know about National Taiwan University, you probably know about Japan's Tokyo University, okay, Osaka University, Hokkaido University, okay, even Korea's Seoul National University. These universities, actually, they were in the Japanese colonial period. They are all Imperial University of Japan. Okay, and then after Second World War, okay, the Taiwan University become named to National Taiwan University, but it was founded in 1928, something like that, okay, as a Imperial University of Taiwan, okay, and it actually is one of the 9 campus of the Imperial Japanese universities, including the Tokyo University. Okay, so this university is the #1 in Taiwan, just like IIT in India, okay, something like that. And after I graduated from this school, I went for 2 year military service in Navy, Taiwanese Navy. And then after that, I came to US to study my master program and PhD program in electrical engineering and computer science at the USC. Okay. So my PhD dissertation is on smart IC design. So it actually is on the neural network. Okay, so very close to robotics. So I work on the smart IC design and also develop the AI algorithms. Okay. After that, actually, I work for Hewlett Packard Lab at Palo Alto, and then go through several startup companies. And then I currently still is a senior member for IEEE. Okay. And I start teaching at Louis about 8, 9 years ago. Okay, so quite a time already. So I like teaching because I like to talk to young people. Okay, I like to talk to young people. And my hometown, okay, I'm living in Fremont, okay, Fremont, California. So where is Fremont? Let me show you in map, okay. I'm sorry, this Facebook always give very yucky picture. I don't like it. Okay, so Fremont is close to San Francisco, about 1 hour drive to San Francisco. Okay, so it's actually on the East Bay. So if this is San Francisco Bay, I live in Fremont is right here, and San Francisco is right here. UC Berkeley is right here. Stanford is right here. So actually around the Bay Area. And myself live in Fremont, and my son, I have 2 sons. One is graduated from UC Irvine, and he's only 25 years old. He worked at the Foster City, so somewhere here for Visa's headquarters. My elder son, okay. My younger son went to UC Berkeley for undergraduate study, and this year he actually graduated from Berkeley, and he actually go to Stanford for graduate study in MSCS. Okay, so both very close to my home. Okay, so I do have the very good experience to help the young people to study computer science, okay, and get into AI program. Okay, get into AI program. I do know a lot about that. So if you have question beyond the coursework, like question like, okay, how to get a job in computer science or robotics or self-driving car, those kind of questions, or should I study for PhD? Okay, those kind of questions I can provide some my own view. Okay, if you have those kind of questions. Fremont. Okay, let's talk about Fremont one more time. Fremont's most famous company is Tesla. Okay, so Tesla is right here in Fremont. And Tesla is on the side of the freeway IA-80. So about probably 3 miles from my home. Okay, 3 miles from my home. This is Tesla Fremont. It was used to be the GM's and Toyota's factory, and later GM sold the site to Toyota, and Toyota run it for probably 10, 20 years, and then they sell the site to Tesla. So I do see the whole development of electrical car, okay, in our Fremont city. Okay, that's actually Fremont. And my hometown, okay, where I grew up, I grew up from Hsinchu, Taiwan. Okay. And where Hsinchu, Taiwan is, you probably never know about this city. But nowadays, if you know that semiconductor, okay, if you know about a company called TSMC, Taiwan Semiconductor Manufacturing Corporation, you talk about 2 nanometer technology. Okay, you talk about 3 nanometer technology. You talk about NVIDIA's what GPU. Okay, they all manufactured by TSMC. Apple's processor A18. They all developed by TSMC, and TSMC's headquarters is in my hometown. Okay, where I grew up. I spent 18 years there from my birth to college. When I go college, I travel to Taipei, another city. But okay, if you have the chance to go to Hsinchu City, actually is the probably has the most semiconductor factory on Earth. Okay, more than 10 of the factory fab in Hsinchu City alone. Okay. So I grew up in that kind of environment. Okay, we have a whole scientific park in Taiwan. All kind of high tech company are there. I think the high tech company there right now probably only Silicon Valley can compete. Okay, with Hsinchu. It's actually really well developed semiconductor area. Okay, so that's actually city that I graduated from. My PhD study, I work on the cellular neural network, and also these three products. I designed a sensor chip for HP Koninka's cooperated CMOS sensor chip before. I also work for the 5-port Ethernet switch for Linksys. And I also invented the input system for cell phone, okay, for multilingual input, Chinese, Korean, Japanese, English, Spanish, all kind of the international languages. So I do have a long list of the publication and US patent, okay, US patent alone, more than 10 of them. So I'm a researcher, an engineer. Oh, I also work on this kind of semiconductor before. Okay, that's about me. And then next one is textbook. Okay. Related to textbook, we'll talk about what kind of robotics we are talking about here. Okay. So the course name is called robotics. We emphasize on modeling, planning, and the control. Okay. Modeling, planning, and control. So let's look at the so-called AI. Let's like look at the so-called AI. Okay, AI, artificial intelligence. Okay, So basically, in the old time, we talk about computer science, right? Computer science. So computer science primarily you do have the hardware and software, right? And you do traditional algorithm. So traditional algorithms that you actually based on the structural programming, okay? Or you based on the so-called object-oriented programming, event-driven programming. Okay, so basically you have some sort of flow chart doing something and then jump into somewhere else and doing some kind of loop somewhere. Okay, you basically design some software like this. This is traditional CS, right? And traditional CS usually is binary, yes or no. It has very clean direction of where we went on. Okay. And artificial intelligence is different. We allow the grade level. We allow some time to jump to different location or something that uncertain. Okay, we allow that. So basically, artificial intelligence, especially the recent artificial intelligence, talking about machine learning, talking about deep learning, like a neural network. So you based on the kind of the neural network you have, okay, based on the kind of the neural network you have, and you have some computational model. You have computational model, and then you based on those computational model, you trying to achieve the optimization. Okay, so most of the time, computer science is solving optimization problems. Okay, most of the time we are solving the optimization problem. We try to have a goal function and try to optimize somewhere. Okay. And then traditional way is that you based on your algorithm and then evaluation tree, go right, go left. Okay, you do evaluate that. So let's actually see something. Okay, let's actually look at something. Let's look at one game. Okay, one game. Let me explain it in the game. So I don't know whether you know Go game or not. Actually, a lot of East Asian people play this Go game. Okay, so let's assume that we actually play this Go game. So if we have the artificial intelligence, if we don't have the artificial intelligence, then you play black and another guy play white. Okay, and whose stone being circled will be dead. Okay, so basically you keep doing that. So your evaluation tree will be one black and then one white. Okay, and then this actually is 9 by 9 grid. So you kind of will end up to be 2 of the power 9 by 9 complexity in terms of uh, the whole complexity. So it's impossible, almost impossible when the Go game become bigger, it can be 2 to the power 361 degree of the computation. It's almost impossible that actually you do exact search and figure out which step is the best step. So then this actually we predict it's hard to have AI to beat the Go game master, right? But since the AlphaGo, it already proven that humans are just junk, okay? Cannot compete with the AI program because AI doesn't actually go on the evaluation tree anymore. It actually can have the small branch and then branch out a lot of them, okay? And then take the beta approach and then branch out a lot of them. Human cannot do those kind of big deep searching anymore. Okay. So even this very complicated game right now, actually human people cannot win. cannot win. So first thing is that in order to make your program that can actually do Go game, you must do modeling. Okay, modeling. So this Go games modeling is very complicated. It's not as simple as this because you try to circle the opponent's get, stone. So you need to know about whether future development will be like this. Okay, different way to circle the white stone. So in this case, this white stone can only escape here by already being circled. So it's actually almost a dead stone. So to evaluate the whole game board and then recognize which stone already dying or which part actually is still alive, you need to have a mathematical modeling. So same thing for our AI, our robotics. Okay, going back to here, okay? We do modeling first. We do modeling first, and then planning, and then control. These are 3 steps. Okay, so this name has meaning. So we do modeling because let's look at the robotics application or robot application of robotics. Okay, so you do have a robot, human kind of the robot. Okay, we call it humanoid robot. So here is a robot, have some vision. So you look at the outside world. So there may be an obstacle. You maybe try to go over it to escape from or avoid that obstacle. So basically, in your computational world, okay, in your computational world, you must actually have the computer vision. And then you actually need to build your own model. So your model must be a map of a few here, your current location. And then there's an obstacle you see, right? And you try to go around it, try to avoid it. So before you can do the control, you have to do modeling, sensing your environment. And by the what you sense, go back to build your model. After you have a model, you try to plan where is your trajectory that you would need to work on to avoid the stone. And then you actually enable your joint of the robot, your wheel of the robot, your track of the robot in order to go avoid that obstacle. Is that okay? Is that okay? Hello? Any question so far?
Questions come. This is
So let's
everything.
look at another application. Let's look at the Tesla, okay, dashboard. Oh, the Tesla car, actually, if you drive the Tesla car, nowadays your Model 3 or Model Y, they all give you a iPad kind of dashboard, okay? So it's something like that, okay? And then they they will build a model on the board. You see that, okay, here I'm driving the car, nearby a few cars here, okay, and there is a traffic light, and right now it's a red light, okay, something like that. You will see something like that, and that is the model. So you use a computer vision to build a model, and then you actually provide the sensing to avoid or give alarm to make sure that your car don't hit on that. Is that okay? And then if smarter, you do full automatic drive, okay? Full automatic drive. That's what Elon Musk recently just announced the robotaxi, right? But Robotech starting from modeling as well. You have to use the kind of a lot of sensor. The model a 3 car, it has all kind of the sensor here, 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 here. Okay, all corners using vision, or some using radar. Some of the auto driving car using radar, but radar is more expensive than visual sensors. So before you actually be able to drive your full automatic drive car, you got to have a sensor. You got to have a radar. You got to have the vision sensor camera to sense your environment. And those environment in your computer build a mathematical model of the environment. And then you manipulate, manipulate your car to go through the model without hitting anything else. Is that okay? Hello? So because of that, the robotics has 3 major steps: modeling, planning, and control. So this is a whole course. We don't have time to teach you to build the robot because we are online course. Basically, we don't have lab. We cannot ask you to build a robot in classroom. We don't. So we focus more on these 2 parts. Is that okay? Because of the limitation that we have for the online course. Okay, so because of that, so we have this textbook. This textbook, robotics, is actually already a well-known book, okay? Modeling, planning, and control, okay? Developed by these 3 professors, okay? And already a very famous book. And actually, they are working on the Prisma lab, okay, and some of the university in Italy, okay. So that's what the textbook we would use, and then okay, whatever. There's a companion website you can check to find some resource, okay. So that's the textbook that we are using. But our material, you can go to the website, okay. And then we have a course shell. We have almost everything you need by the course shell, okay? I think that we do have a link for PDF for the textbook. You can download a PDF here, okay? You have to search. We do have the link to the textbook, okay? So you search through our course shell, you should find some link for the textbook. But basically, we based on that textbook to develop this course. Okay. Okay, let's look at the syllabus one more time. Okay, so there are all kinds of the robot, some human-like, some actually like a tank. Okay, some maybe like a wheel type, some like look like spider. Okay, all kind of the robot. But in a way, robot control is the same. Okay, no, here. Robot control is the same. You do modeling, okay, planning and control. Okay, so here we do have a control loop. Okay, we do have a control loop. And based on this control loop, let's look at it. Okay, so you do have a sensor. That's so this is a robot arm. Okay, it's a robot arm. So this manipulator would control the arm to reach for some obstacle or some object. And then this robot maybe have some visual sensor or ultrasound sensor to sense the environment. So basically, you take in the information from the sensor to see where the object is, and you try to use the robot arm to reach it. Okay, so those kind of sense information sent back to your computer and you build your model. So here you do have a model being built. And then you have your own trajectory planner. You plan your robot arm, and based on the model you have, you control your controller, and your controller doing optimization control calculation, enable your actuator, and your actuator move the motor of your robot arm, and then you try to reach for the object you want to reach. So this is actually a full feedback loop. So for the textbook, the chapter, okay, chapter, let's see, each chapter number, okay, starting from the modeling, chapter 2, chapter 3, appendix A, chapter 7, these are talking about the transformation and kinematics. It's actually talking about how the actuator and the manipulator work for each different chapter. Chapter 5, chapter 6, talking about the sensor and overall architecture. So you talk about this and the whole loop. This is chapter 5, chapter 6. And then chapter 4, chapter 11, chapter 12, talking about how you do planning and optimization. So that's the planning part. Okay, there are more things that actually related to motor control, force control, visual servos in feedback, and then these are related to the control. Is that okay? So basically, this chart tell you each chapter related to what, okay, the topic that we are talking about. But we don't only have 8 weeks. We have to somehow mix everything to teach you the whole thing, okay? We cannot teach one chapter per week or one chapter 2 weeks. We don't have that kind of time. So we have to actually make things that it can be done within 8 weeks. So next one is talking about a grade, okay, final grade. So we do have a lot of homework and test and discussion board. So each one of them have some point, say discussion 20 point, quiz maybe 100 or 150, okay, whatever. So there are certain point that you actually have, okay. And then you have quiz and you have homework, you have project, you have 10 projects. So your your all point, your total point that you earn will be divided by the total point available. And you get a number, say 93.5. We'll give you grade based on this number. Is that okay? So as when the time keep going, you will accumulate a lot of point, and then you just divide it by the total point that you will end up knowing how many points you have. You will know about whether you will get A or get B. Okay, so that's actually the so-called accumulated point system. Okay, so very simple, very straightforward. So there is no need to negotiate. Oh, I should get an A or I should get a B. You can calculate your own score. Okay. And one thing is that we do have a extra point. Okay. So if you look at the grade book, if you look at the grade book, and then we do have participating point. So this one actually is not based on your homework. It's actually I use this extra point to do curve. So basically, if we a whole class, a lot of people is actually score is very low. Okay, very low. So that's assume that A is right here, B is right here, C right here, D right here, okay? And then the majority of the student is like this. Actually, is like maybe like this. Okay, so I may use the this curve point. It's a 300 point. Then I may make a curve look like this to shift it, the curve the whole class. Is that okay? Hello? Any
Yes,
question?
sir.
And how I control it? Usually, I try to control the A student to be between actually 1/3 to 2/3 of the people between here. Okay, so if the whole class has more than 2/3 of the people got A, I think that's too many. Okay, but if the whole class actually below 1/3 can get A, I think that's too harsh. So I'm trying to use the curve line to move the grade. So basically, possibly fitting into this range. Over the year, this one worked quite well. So what I want to say is that usually students get a better grade than they really the overall point that they earn based on the curve line. So the curve line actually are based on the participation of the course and then question they ask, okay, those kind of things to determine overall curve point, how many the whole class should get. So when we do curving, it's not individual, it's actually the whole class, everyone at 100 point or 50 point, depending on the whole class participation. Is that okay? So there are certain year, a lot of students show up for meeting. There are certain year, none of them show up. We all experienced that before. So we have to determine that whether this group of people really work hard or not. Okay. Any question? But my guideline, okay, to be honest, my guideline would be controlling A to be
Sir,
yes.
for the presentation, like we need to perform in a Zoom class, or we need to record and submit.
I'll talk about term project later.
Okay, thank you.
Okay. I'll discuss it later. Right now about the score, any questions? So each one of them you will get some score anyway, right? And when you end up to have a certain score, they like 2,700 something. Okay, you divide it by total point that you actually allowed to earn. That actually is about 300, 3,600, right? Actually 3,000. And then I may give you a curve, maybe plus 150 or 100. So you get a total point like this. So this 100 will not be added to base. No, it will not. Is that okay? So it will give you some curving power. And my goal is control the class to be this way. Okay?
Okay, Professor.
Okay, so that's actually our goal, okay? But usually last year, actually, I almost like 14 student or 15 student. I think 90%, more than 90% got A last year, okay? Last year's participation is quite good, quite well. Okay, so everything that were due, okay, according to the due time, so submit the homework early. But if you have to be late, I will take all of the late submission, okay, until when? Until the last day of the class. So what is the last day of the class? Let's look at it. We start the first week right now, okay, so in December, okay, I'm sorry, this is not good. Let me actually bring up the calendar. So let me turn the calendar to months. Okay, so we go here, November to December. So December, I believe that our last day of the class is right here in December. I think the last day of the class is either Friday or Saturday. Okay, it's okay. So our real due date is the 11:59 p.m. of the Sunday of the December 15th. Any homework submitted before the end day will be graded. If you submitted like 12:03 a.m. of the Monday of the 16th, sorry, you receive 0. Is that okay? Is that okay?
Yes, sir.
So your real due date is right here. Any homework the same. You want to late, I'll allow you to be late, but cannot be later than this one. That's the real due date. But in a way, I give you the maximum flexibility to arrange your own time to submit your homework. But do not actually postpone the submission too much, because some students in the past years, they do submit the homework at the last week. You cannot finish it too much, okay? My experience is that you cannot finish it, okay? So try not to accumulate too much of the homework. You try to finish according to the schedule. That's the best, okay? Don't accumulate too much. If you are ahead of schedule, that's fine. You are welcome, okay? We don't force you to, you actually can study at your own pace. We don't care how early you submit. So some of the students actually 1 week before the last week already cleaned up everything. That's fine. It's welcome, okay? And then why we have to pick a due date of this time? Because usually Louis University require the teacher to submit the grade report in the morning of the Tuesday following the last week. So usually it's like 8 a.m. Pacific time. So it's like 10 a.m. Central time. So in a way, Tuesday, I cannot work anything. So Monday, I have to finish the tabulation of everything and submit a grade. I don't want to wait until Tuesday morning. So because I want to have 1 day to tabulate all the students' grade. So I pick the real due date at the midnight, 11:59 p.m. of the Sunday as the cut-off time. Is that okay? That's how I plan this way. So I have 1 whole day to tabulate every student's grade. There are 20 students usually. Or sometimes 30 students. I need to calculate everything for them. Okay? I need 1 day to do that. Does that make sense? Okay, so this is about grading. Any question about grading so far? Move on to other topic now. Any question about grading? No? So from week 1 to week 8, we have different topic. Okay, that's actually fine. Okay, background, you do need to have some of the courses and college requirements. So you download the syllabus, they'll tell you, okay, this one, okay. Now let's move on to the next topic. Let's look at the term project. Okay, some student ask for this one, the turn project. So every week we have some homework, we have some programming assignment to be finished. Okay, and it actually all in most of them in mathematics or in Python. So please give me the Python file. The .py file is okay. Some students give me the so-called notebook file, IPython's notebook file. I don't like it, okay, because to me actually it's more difficult to grading. So I accept the .py file. If it is a program, just give me the plain Python program, okay? Okay, don't give me the notebook file. It actually not easy to handle. And then if you have written program report, you give me the PDF or you give me the Word file. That's actually acceptable. Okay, acceptable for the writing part. Okay, that's about the format of the file. Now let's look at the term project. So every week you have some quiz and you have some programming assignment. Okay, but this one actually we do not, they are all on the mathematics and planning and modeling. So we do have a term project so that you can really work on a robot or build a mathematical model. Okay, so we depend that for you to learn the control part, even though we don't have lab time to help you. Okay, so that's the part we wish you to build your own robot. Okay, so this one, the term project is the most essential part of the course. We set up the requirement for a term project in every one of our course. Okay, any course that I teach all has this term project. Okay, and then what should I do with the term project? Okay, so they are project ideas. So this project idea is only for suggestion. You do not have to work on these. Okay, it's only a suggestion, but usually students don't have idea what they should do. But this one is an open project. So as long as you work on something related to robotics, then it's okay. But usually we suggest students to go three direction. Number two, you assemble a robot and test it and make it work. This one is a typical project that some students take. So for this one, say that's actually assume that you actually go to say Amazon, okay, and you actually search for programmable robot. Okay, you buy one of these, you assemble it and test it, and actually okay. You order the material by yourself. You don't use any of these well-assembled kit. That's also okay. You try to build your own robot. Is that okay? Hello? So that's the project two. Any questions so far for this project idea two?
Just real quick question on that. So for this term project, are we gonna need to like, run the idea by you and everything by a set date and then, we go from there?
You can get started now. Okay, you can get started now. You have the whole 8 week to work on it.
Gotcha. Thank you.
Okay, you don't need to wait until week 3 or week 4 to start. No, we don't have that limitation. You can start from now. You can buy some of the material if you want. Okay. Anyway, let's actually look at one example. Okay, let's use the code shell. So every year I do have the I do have the recorded session. Okay. So you go to the week A. After week A, there will be a recorded session. So here we do have the 2024. Okay, 5 years already. Okay. So let's look at some of the year before. So here at the end of the year, let's see. This year not good. Okay, this year for some reason we don't have the students submission. Let's go to 2021. So we do have some of students' video right here. Okay, this one is a very good example. So there's a student who actually
Okay, here is a project.
Mhm.
It is the toilet robot. It is a robot that is designed to play music while you are using the toilet, as well as close the lid when you are finished using the toilet. And so before I
Did you hear what he said? Do you hear it? Okay, if you hear it, it's okay. I just want to make sure you all hear it, okay?
plug it in, show you how it works, talk about design philosophy that I use, because a lot of things are going to happen when I plug it in. So I like to check everything is working, let the user know that everything's good before it actually starts anything. So what we're going to see, it's going to be difficult to catch, but these two lights are going to turn on to show that they're functional. This music is going to play. And this servo down here is going to engage and set its position to 0 degrees. And so the reason for all of that is just because I want to know that my robot is in the state that I want it to be before I give it any commands. And so once it exits that state and plays the music, it's going to shift to the ready state. And this green light is going to start blinking green to show that it's ready to go. So what we're going to do is we're going to plug it in. So we got servo move, lights, music. Okay, so it's now in the ready state. We can see that by the blinking green button. And so down here is our ultrasonic sensor. And I have to be very careful to trigger it because I don't want it to accidentally think that I've finished using the toilet, so to say. So I'm going to stick my hand right in front of it, and I'm going to try not to move it. So it's changed to the red state, and we can have we have the music playing in the background. This would be, that the user is using the toilet. And so when the user finishes using the toilet, it's going to stop playing music and shift to the ready state, green, and it's going to also close the lid to the toilet. So we can imagine that our user has finished using the toilet, closes the lid to the toilet, and the music stops, and it goes back to the ready state. And so that's really the functionality of the robot in a nutshell. I'm going to try to maybe give this a little bit more of a shell and maybe, bring out an extender and all of that kind of stuff if I get the opportunity to do so before I pass this in. But that is the functionality of the robot. And thank you very much for watching.
Okay, anyway, he actually later submit a second submission of the video to make it complete. He really installed it to a toilet, okay? So basically this one is actually a very good example. He do good, get a very good score. Even though the robot is not very complicated, but we just want you to be creative. So the judgment usually when we do the grading is based on the creativity more than the complexity. We don't care about the complexity. So if you have the time to buy the component and then assemble it, this is the idea too. Okay, if you don't, you can work on the mathematical modeling. Say you try to model this KUKA's robot arm, and write the Python code that we teach you in the class. This is also okay. So this is project idea number 1. You do not have time to build a robot, so you build a mathematical model for it. That's fine. The planning part, okay. You want to build a robot, that's okay. Okay, if both of them you don't want to do it, you want to create, you just want to study papers and then write a creative idea for brand new application, that's also okay. You don't need to build a robot, you don't need to build mathematical model, but you need to present an idea. So let's talk about it, idea number 3, okay? So this is number 1, we want you to show the mathematical modeling capability. Number 2, we want you to really build a robot, okay? And if you are not good at both of them, you want to create a new idea, you have to tell us what is the idea that you present. So we evaluate the third one based on the idea. So say, can I actually show the idea of the iRobot to have a bacon circling around a room and then clean up? No, that's not new idea. So this project had to be brand new idea. We don't take any commercial product as a new research, is not. But do you need to finish your research making sure that it works? No, we don't. You just need to present a new idea. Is that okay? Is that okay? So
Yes, Professor.
usually 3 kind of the topic you can pick. Number 1, you build a robot by yourself. That's actually typical. A lot of students pick this one, okay? Or you don't have the money, you don't have the time to build a robot. You want to just build a mathematical model that we teach you in the class. That's also fine. And if you don't like the math, you don't like to work out a robot, but you do have a lot of ideas, say, okay, anyway, the toilet robot is one of the good example. Actually, who will know about that, okay? That actually is an idea. You want to do that, you can implement it, or you don't have time to implement it, you just want to present the idea. You can give us your study for any of the new robot you think of. That's actually exploring the future. That's fine. Okay. So basically, we actually need you to, in the week 3, we need you to submit a 100-point worth of the project proposal. And then week A, I need you to submit a final report. Okay, let's talk about this. So the week 3 one, you just need to do the project proposal. So what is the project proposal? Project proposal is you try to propose your manager, your boss, your sponsor, that your project is doable. So it's actually a persuading job that you need to present the idea, what's developable, what kind of tool, what kind of material that you need. Organize it in the written reports. But some students write 3 lines of the description. That's bad. Some students write 50 pages of the proposal. That's also bad. I don't need you to that. So usually proposal like 2-3 pages is normal. Is that okay? Hello?
Yeah,
I do not
Yes,
expect to give me a 50 page thesis. That's too long. No, I don't have time to read that. Okay. And if you give me just 3 lines, actually that's not a proposal. You cannot convince me to fund your project. So this purpose is you try to learn the proposal, making proposal to your manager. I think this one is some sort of training that you will need later when you go to job. Okay. Okay, this is proposal. Then final report. Okay, final report. Final report, you actually not talking about idea. You already done the mathematical model or you already build a robot. Okay, you already build a robot. So you need to write a technical report and a presentation. So let's talk about presentation. Presentation, you can make a video. You can have a PowerPoint if you don't have time to make a video. Either way is okay. But this presentation and the report is different. These two are different. Final report, you have the written format, so you need to talk about some mathematics, some theory. But PowerPoint, please not, okay? I don't need that theory in the presentation. I just need to know what you have done. Is that okay? Is that okay?
Yes, Professor.
So the presentation, you just need to show me what you have done. So a perfect example is the previous one. This is a toilet, project, okay? Toilet robot project. You just tell me what you have done and how it functions, how it works. That's all I need to know in presentation. So you are given like maybe 2-3 minutes to make the video. In the 3 minutes, you need to show the whole idea. But also don't give me a 1 hour video, okay? I don't have time to watch that long as well. You need to present how your project works in 2-3 minutes. Okay, in 2-3 minutes. But the technical report, if you want to write some mathematical formula or something, you have to put it in the final report. So the final report should including how you work on a project, what is the theory behind, what is the tool that you use, and how you work on this project. That's actually in technical report. But in PowerPoint, don't put that. Put those things in here. I just need to know about how your project works. Okay. So you need to include a technical report. You need to include a presentation file or video link. And you also need to include all the technical file, your Python file, your Raspberry's picture, whatever, design schematic. Is that okay? So final report, including these 3 parts. Okay. Any questions so far? So in a way, your term project, the main purpose of this term project is that you must be able to make proposal. Also, you must be able to complete a project. So later, when you try to go to a job hunting activity, you can present your project to your future boss. Is that okay? This actually is a job preparation training. Okay? Any question? So there is a lot of students may ask, okay, if in the week 3 I make the proposal, I want to build a robot, and then in the week 8, when I submit the final project, it actually build a tank. Is that okay? Actually okay. The proposal and the final report we evaluate separately. You can change the idea. We are not actually limited to whatever you propose. So it's a separate evaluation of the homework. We don't check if you are submitting the same idea or not. Is that okay? Hello?
Yes, Professor.
So there's no need for you to send email to tell me, oh, Professor, I actually in week 3, I want to do a soccer project, robot kicking soccer. But week 8, I build a airplane drone, actually not related to the soccer player. Is that okay? You don't need to ask me. You just do it, okay? You just do it. I actually don't care your proposal, whether it's linked to your final report or not. But one thing, please don't copy or don't use the material that you develop in like CS 222555 that machine learning or something else. Don't use those kind of project to here. I'll give you a 0 if I do see that you actually copy from somewhere else or sharing the project between two cores. I'm serious, okay? This actually, I really be very serious. I want you to be creative, okay? Incomplete project will be accepted, but something that actually copy from other cores will not be accepted. Is that okay? Hear me? Incomplete project is allowed. You may suffer some deduction, but you will not fail. But if you copy and we prove that, then you may get a 0, non-negotiable 0, okay? Because we want you to be independently study this, okay? There's another question that, okay, may I team up 2 people to work on the term project? I would say no. The reason why this course doesn't allow the team project just because this is a remote course. So we almost impossible to check whether a student working on this project 90%, the other one 10%. We have no way to verify it. You know what I'm saying? So with that said, we just want every student to be independently working on it. Sorry, if this actually is a remote course, we do not allow teamwork. Okay? Does that make sense? So if I'm teaching this on site in the campus, then I will allow teamwork because we know we just call the people involved in the project to present it and who's work on this for how many percent. I actually really have easy breakdown of the grading, okay? But this one very hard because we are online and you send file to me, and how can I know that file 1 is done by this student, file 2 is done by the other student, and then they argue. We don't want to go into that kind of situation, okay? So we do not allow teamwork for the term project. Sorry for that, okay? We try to avoid conflicts. Any question?
So, Professor, it is not a team project, right? So it is an independent project, right?
Yes, individual project only, okay? So you learn more as well. Okay, literally, but grading will based on, grading is always subjective, okay? Actually, never be fair, I would say that, but we try to be fair as possible. But I mean, no one is perfect, right? So we try to judge you based on originality, creativity, completeness, difficulty, and presentation style, okay? And usually I try not to, if your project is especially good, I may give you some bonus point, more than the point that you know, okay? Homework the same, I may give you bonus point, okay? So maybe one homework is 150 point worse, but if you do extra work, you may receive 160, maybe it's possible, okay? Any question? But grade is always final and non-negotiable, okay? We don't do regrade because we are remote and I don't want to have the time to keep back and forth, just argue with students for the grade. So you better just do it well, okay? I only accept negotiation. If the calculation of the grade is wrong, then I may change. Okay. But once we reach a certain grade or certain score, that would be final. We don't negotiate for that. But if I sum up the grade or score in the wrong way, okay, because of poor calculation, then we may change. That's the only case that we will change the grade or score. Is that okay? But usually we don't go into that, okay? Usually our students are very happy about my grading. I give you the maximum flexibility. We don't force you to always submit homework on time. I'm not the kind of teacher that if you are late for 1 hour, you got 0. I don't do that, okay? I wish you to have the maximum time that you can have and enjoy the project and homework and programming assignment so you learn more. But with that said, I also don't want you to pile up everything until the last week, even though I accept every day submission. But that's not suggested because you will not be able to finish everything in 1 week. Don't do that, okay? You are asking for trouble, even though that's allowed, okay? So you don't have the need to tell me, oh, professor, I need to go to India for 1 week. I will be late in my homework. No need, okay? You are allowed to do it. Just go. Is that okay? Does that make sense? Hello? Or I need to, on Thanksgiving, I need to see my parents. My homework had to be late. That's not a problem. You can work on it before the due date. You can work on it after the due date, but never be late after the final due date. That's on the December 15th midnight. You pass it, no grade. Okay. That's the only due date we have. And any other arrangement for your schedule is all allowed. Okay. Any questions so far? Okay, this is about grading and final project. Any more question about a project and schedule, idea, and grading? Any? Hello? No?
So Professor, the project is individual project, no teamwork is needed, right?
Can you repeat again? I kind of on
So
and off.
my question is, we need to do individually, no need to make a group and do the
No
project, right?
need, no need. It's individual project, yes.
Yeah, okay. Like if we want to do it, like a team project, is it allowed or it is not allowed?
It's not allowed in team format.
Okay, so we are having 20 members in our class, so you are expecting 20 different kind of projects, am I right?
Must be a new project. Don't copy from anywhere else.
Yeah, I got it, Professor.
No teamwork because I cannot differentiate. You work on here for 50%, the other guy just 1%. I have no time
Yeah,
to verify. You know what I'm saying?
yeah, correct.
That's
Yeah,
the
I
main
understand that
reason.
one.
That's the main reason. We are remote, so we cannot check you. Oh, you complain that hey, my colleague, my friend never work on it. It's all my work. Oh, then I don't have time to verify it. You know what I'm saying?
Yeah, but in the syllabus it is showing like members, three members something, so that's why we are getting confused here.
Yeah, very complicated. And also, I want you to be creative by yourself. So
Okay, and also,
teamwork is very hard to evaluate that. You know what I'm saying?
yeah, we have three options, right, Professor? Like one is the coding part, and another one is the assembling the robotic kit, and one of the creative projects that will be new.
Yes, this is a suggested list, but go back to
Yeah,
the fundamental idea. Anything related to robot is acceptable.
So like just now you were showing in one of the Amazon website, one of the prototype robots we have. So we need to assemble those things and we need to explain how it is going to be
Yeah.
working. Am I right?
So it can be all kind of project. We do see all kind of project. You see this one in the toilet and the other one actually working on a assemble robot. Okay, this one. Let's see this one. He do open actually buy a kit, okay, and then whatever he want to do, he actually videotaped everything that he work on. Is that okay? That okay? I welcome this. You know what I'm saying? There's no talking, nothing. He just keep assembling. That's okay. You see, this project is another type. What I want to see is this person really work on it. Technical job, okay. No need to be theoretical. Okay? You don't need to invent anything. As long as you learn something, that's fine. But do not borrow a robot that built by other people to here. It doesn't work. Like this person's project, I like it because he videotaped a whole process of building his own robot. And whether his robot work or not, I don't care. I cannot verify as well. I just
But
need to
Professor,
know that, yeah,
Professor, what about the documentation part for this kind of project?
he just document down how you work on it.
So no need to submit any kind of documentation, right?
No, you have to.
Then what it's going to be?
So he made, okay, let's finish this one, okay? So he show how he work on this one. So in terms of writing, he write down what kind of package he buy, and then how many example work he have done. Week 1, what he did work on it. Week 2, what he work on it. And also working on why he picked this topic. Those kind of things, anything related to the project is allowed to writing into the report. You know what I'm saying? It's a report
Yes.
of how you work on the project. So presentation-wise, I don't need to have those kind of writing. I just need some video or some PowerPoint like this. That's actually good. And then the report, you can write how I develop it, what is the material that I get, okay? That actually is fine. That actually is fine. It's not a PhD dissertation, so there's no need that you must include math. No, not really. You need to include math. He do show he work on it, okay? And then there's a small display board. And he also showed this Arduino's programming interface. So this is a good project. He doesn't invent anything in a way, but it's okay. We are not PhD study, okay?
So our motto of our project is we need to learn something by doing this activity. Am I right?
Yes, as long as you learn something, it's okay.
Either we need to invent or else we need to learn something from the already invented robots.
Don't you just have some project idea that related to robot, that's okay. But do not copy. That's a problem.
Yeah, either we need to
Do not
learn by
copy
doing.
means that you can buy a robot and assemble it, but do not copy the video from someone else.
No. Like
You know
it
what I'm
is our
saying?
own assembling video. We need to prepare like what are the things we learn from buying the like assembling the robot and what we learn while
Whatever
assembling.
effort you work on the project, you can document it.
Yeah, okay.
So where you buy the robot, okay, and what kind of work you work on, how you do the testing, how you actually assemble something. You need to document anything that you need to document down, you write it down, okay?
Yeah, okay, Professor.
This is another kind of, so the toilet sensor and this example project, they are actually, even though they all build a robot, but they are different, and both of them are good, okay? I should say both of them are good project. Any other question? Okay, this is about 10 project. Let me see anything else I want to cover today. Okay, final one. Final sense that,
And
yes, go
Professor,
ahead.
regarding the week-wise quizzes, we are having some kinematics related images to identify which one is correct and what is the equation or what is the correct suitable model, some related questions, right?
Yeah,
Like few of the questions will having thumb rule something. So Professor, can we get few of the samples solved questions so that we can get familiarize those things and we can give our attempt on quiz questions? Because during the material, like we need to watch the video, even though we are watching in the video, these kind of quiz questions are not discussed properly. So if we have any already solved examples so that we can
usually
practice
the
those questions.
question, usually this
Yeah,
Monday session is question based. This
okay,
Monday meeting, you allow, okay. Number one, if you have a short question, you can contact me by email or the message board here, or you contact me by my Facebook. Okay, let's actually talk about this. My Facebook actually right here. You can just type HTTP, okay, and then facebook.com/DR Dr. Eric Chow. That's my Facebook. And you actually text me the message, I will respond you, usually within a day. Okay, you add friend to me, I will actually respond you using the messenger. Okay, here actually I have a lot of students actually communicate. I'm not just teaching Louis, I have some other students. Okay, so this is my website, the facebook.com, and Dr. Eric. If you go through the email, it's also okay, but I cannot guarantee that I read the email every day. I cannot, okay? Let me see. Okay, I cannot guarantee that I read the email every day because that I'm not a full-time professor here, so I'm just teaching part-time. So this email system to me is extra work. I may not come in. I may check 2-3 days a week, okay? But the more direct way of contacting me is sending the messenger through this group, okay? Is that okay? Or
yeah, okay, Professor.
you email me. Email maybe 2 days, 3 days the delay, but messenger I will guarantee within a day. Okay, but if you want to talk to me in person, then actually usually Monday, the time that we have right now, okay, the noon time, is always a good time to discuss. Okay, and then if you send me the messenger and your problem is a little bit more complicated, then I may Zoom you sometime. Okay, is
Yeah,
that
okay,
okay?
Professor.
Okay, that's about the communication part. And then let's see, the course share. Let's look at the course share. So right here, we do have, every week we have the material. So let's just say week 1. So in week 1, each topic we have pre-recorded. Okay, so week 1, you actually need to watch the video. The video usually each week have 2 or 3 hours. It's quite a long video. So we do not teach you again because that's really long. Okay, so on Monday we don't have the time to go over everything again. So you need to depend on the video. Okay. So there is a video. Let's see, lecture. So there's a video you can watch. Okay. And then each one of them, you do have the PDF. That's the slides that we use. Okay. And then if you have a question, you can ask through Messenger or through email, but usually Messenger is faster. Okay, any question?
Professor, most of the videos are covering only theoretical part. When it comes to quiz questions, we need to do some mathematical part and then we need to analyze some figures. So this is not discussed in the videos. So how can we solve these quiz questions? So that I am asking, like, is there any material we have so that we can practice our material and so we can give our quiz attempts?
Question depends on how difficult it is. If you can, okay, if you actually have those kind of mathematical question, you post the question to the messenger. I'll try to see if I can help you. Okay.
Yeah, like Professor, for the week two, you can see like we have one model, like how many joins, how many links we need to calculate, and some
You
some
have to
kind of questions. Yeah.
sometimes you have to figure out because some students' problem is not mathematics itself. It actually is not programming itself. It actually is a question about you don't have enough mathematical background. Now in that case,
I'm not worried about the mathematical background, Professor, but I'm talking about the like whatever the videos recordings we have that is not relevant to the quiz answers, quiz questions. It is not completely cover the quiz related questions.
it's not what to the question. Can you repeat again?
So the quiz questions is different and the video lectures is presented in the week wise sections is different.
Can you give an example of what kind of question you actually would be facing?
So for week, can you go to week two quiz or any kind of week three or any kind of quiz? So once you open, like you can see some figures or images related to the kinematics.
Those actually in the video you will see they are video.
But you are not.
You have to watch the lab as well.
I go through each and every video, Professor. That's why I'm getting
I don't think
confused. Like
so. I don't think so. Our lab is related to the questions. As I said, we do have two sets of the material. Each individual quiz, we do have some of the video related to it. Not this one. Let me see. I'm sorry, I used the wrong one. Each of the problem we do have the related video related to the problem you have. We explain this well in all of the videos. Okay. So the question you ask doesn't exist. Every video, including the lab, you need to watch it. It do teach you all kind of the problem that you need for the quiz. Okay. I guarantee you because I developed the lab before the questions of the quiz. Every week, not only the lecture, they are also have the lab. The lab is usually how you operate or how you calculate some problem. Each one of these, you do have PDF that you can download, and it's related to all of the problem we have. Okay. We all has that. So you have to finish, okay? For the course shell, you need to finish not only the lecture, but also the labs. The labs teach you to work, how to work on those problems. Does that make sense? Or some of the math like linear transformation, we all have even the video to teach you that, okay?
Don't focus on results. We focus on what leads to results. With Smartsheet supporting our operations, the results will come.
No one thought this could be done.
That's Gavin Newsom signing the strongest rent control law.
So basically, we have all kind of information that actually teaching you how things are done, okay? I guarantee you all of the code shell that we have is very complete. Is very, very complete. Because we use this code shell for many years. There's never a question of I don't have this material or that before. Our set of the information and teaching material is very complete. It's just whether you find it or not, okay?
Okay, Frankie sir, thank you.
You just try. I mean, what I want to say is that you just have to try. It may be somewhere that you actually usually is in the same week. In the same week, you not only need to finish the lecture, but also the lab, also the extra reading material. They are all supporting your assignment and quiz, okay? So lecture is like going through the chapters, more theoretical. Labs are those kind of hand-on experience, teach you how to calculate, teach you how to model, teach you how to draw diagrams, okay? But it's a good question. Any other question? Okay, if no question, usually Monday morning we go around 1 hour, okay? Go around 1 hour, and usually depend on how many questions you have, okay? But usually it's noon time, so you have a 1 hour break or 1.5 hour break. It'll be enough for you, okay? But before that, before the meeting, you can always reach me by the Facebook or email, okay? Okay.
Professor, is it mandatory to attend every day online class on Monday? Every Monday we need to attend online class?
Where I don't care, as long as you log in.
Like we are not capturing any attendance, right? And also few of the students also
Yeah,
not attending.
but every week after the meeting, actually, usually I will usually after I'll put into the recorded session.
Okay.
So here every week I finish the discussion. I will post the week's video. So say today I have a meeting with you. Maybe later today or tomorrow, I will post today's video recording for this Monday morning session. Is that okay?
My question here is, Professor, do we need to mandatory to attend the every Monday class?
No.
No, right? It is an optional, right? If we have any doubts regarding week-wise questions or concerns, we need to attend and we need to sort out them, right?
We encourage students to participate, but I never actually go through head counting. No.
Okay.
I want
you,
to give
Professor.
you the maximum flexibility. But if you do have question, you actually have to ask. Don't tell me that, oh, I never attend the class, but I need to answer your question. That doesn't work, right? You have question and you don't show up, how can I tell you? Right? You know what I'm saying?
Yes, Professor. Yes, I understand.
But if you don't have question, you actually want to do something else, I don't care. I really don't care as long as you can submit the homework. Okay? In a way, I give you the maximum flexibility, but you have to respect yourself. That's what I say. If you really are actually not able to make it, you have to make sure you watch a video, okay? Or if you have no question, that's fine. If you have question, you do have to ask. But there are students who actually end up have a lot of questions, but they never show up in the meeting, never ask question. That's not good, right? They actually not really spend their time well. Okay. So here, this one for 2024, this one so far no video because this is prepared for this year. And then this one actually is last year. We do have the last year's all of the meeting video, okay? So meeting minutes always be recorded and being posted. Okay? Any other question? Okay, if no question, we are going to stop here, okay? But you are welcome to contact me by email or Facebook, okay? And you're also welcome to show up on Mondays. Okay, see you next time, okay? If no question, see you next time. Bye-bye.
Thank you.
Bye-bye. Thank you.
Thank you, Professor. Bye.
Thank you.